I want to look at one more example that explores the relationship between position, velocity, and speed, particularly looking at the graph. So not being too concerned with the algebra behind it, but really looking at the graph and digging into the graphical interpretation of the derivative. So here I have the graph of a position function, s equals f of t, moving along a line at time greater than 0. So we're really only concerned about positive time here. Part A says for what values of t is the velocity 0? So here, notice we're saying velocity. We're not saying average velocity. We're just saying velocity. So I'm assuming we're talking about instantaneous velocity. Instantaneous velocity, just another way to talk about the derivative f prime of t, or s prime. So where's the velocity 0? Well, hopefully we kind of know where this is going. If my velocity is 0, what does that look like graphically? We've gone kind of the other way a whole bunch, but now, I'm starting with a velocity of 0. What would that look like graphically? That means have a horizontal tangent line. So where do I have a horizontal tangent line is essentially what this problem is asking me for. So let's see. It looks like I have a horizontal tangent line. I bet you could make the argument here at 0. I have a velocity of 0. It is kind of hard to see right here, and I think you could make the argument either way. I think I would probably say that the velocity is 0 at 0 though. Where else do I have a horizontal tangent line? It looks like right here at positive 1 I have a horizontal tangent line. At t equals 2 I see a horizontal tangent line. And at t equals 3 looks like I have another horizontal tangent line. So that's awfully convenient, isn't it? So what values of t is the velocity at 0? At t equals 0, 1, 2, and 3. So okay, that answers that question. So we were just, again, looking for where do we have those horizontal tangent lines. Part B says when is the object moving in a positive direction? When is it moving in a negative direction? What I would suggest doing here is I would actually make a number line. I'm going to think about, okay, what is the velocity doing at each of these? So for the velocity, now we start here at 0, so I want to include all of these points right here. What's going on at those points? So 0, 1, 2, and 3. And we said that the velocity was 0 at each one of these. So I'm just going to put a little 0 above each one so that I remember that the velocity is 0 for each one of those t values. So what I want to look at here is, again, remembering that this is the position function. If I want to talk about the velocity, I'm talking about the derivative. So I'm essentially talking about the slope of the tangent line. I'm going to pick a number between 0 and 1. So any number will do. How about this right here? I'm going to sketch in the tangent line. It doesn't need to be the whole tangent line. If I look at that point right there, that slope of the tangent line that I've drawn, is that a positive slope or a negative slope? Well, this slope, it might be hard to tell, but it's positive. It's increasing. So if the slope of the tangent line is positive, it means that the derivative is positive, which means that the velocity is positive. So that means that my velocity is positive between 0 and 1, because if I look at the slope of the tangent line, I have a positive slope. And I'm going to repeat this process again and again. Let's look at between 1 and 2 now. So if I pick a number between 1 and 2, let's pick this point right here, and I sketch in the tangent line right there. I'm going to ask myself, okay, I've drawn in my tangent line. What's the slope of that tangent line? Is it positive or is it negative? Slope of that tangent line, it's decreasing, so it must be negative. So that means that the velocity must also be negative, because that also represents the derivative. between 2 and 3 now. So between 2 and 3, I'm going to pick, this point right here. Why not? I'm going to sketch in the tangent line. It looks something like this. What's the slope of that tangent line? Is it positive or is it negative? Line is increasing, so it must have a positive slope. All right, one more time. After 3, so anywhere after 3 will do. Look right here. Draw in our tangent line. It might look something like this. Does that tangent line have a positive slope or a negative slope? Well, that line is decreasing. It must have a negative slope. So what I've looked at here is I found the velocity. I found where the velocity is positive and negative, and then positive and then negative. I've kind of identified where is my velocity positive and where is my velocity negative. But remember that velocity isn't just how fast you're going, it's how fast you're going and what direction you're going. And that sign of the velocity, that's what tells us whether we're moving in a positive or a negative direction. So when I want to know where I'm moving in a positive direction, what I'm really looking at is where, if I want to know a positive direction, I'm going to say, hey, where is the velocity positive? Well, it's on these two intervals. It's between 0 and 1 and between 1 and 2. So when I talk about a positive direction, let's say positive here, it's positive between 0 and 1. Now notice I'm already using parentheses to show that those numbers are not included, because if we already said earlier that the velocity was 0 at 0 and 1 and 2 and 3. So, between 0 and 1, and where else? On this interval right here, between 2 and 3. So 0 to 1 and 2 to 3. What about a negative direction? So a negative direction, negative. So let's highlight those in blue. So it's moving in a negative direction wherever my velocity is negative. So right here and right here. So it's moving in the negative direction right here. That's between 1 and 2. So between 1 and 2. Then also on this interval right here, between 3 and, well, we don't really have an endpoint right here. You won't have another spot. Here it just says time is greater than or equal to 0. There is no upper limit on time, and it looks like my graph is just going to be decreasing forever after that. So we'll say from 3 to positive infinity here. So that's how I can look at this and tell, okay, where is it moving in the positive direction? Where is it moving in the negative direction? Part C says to sketch the graph of the velocity function. So I want to sketch the graph of the velocity function. Oops, let me get rid of these. And oops, I lost my plus sign. There we go. Okay. And let's get rid of this. Okay. So I'm going to draw my velocity function in red here. We said our velocity was 0 at 0, 1, 2, and 3. So if I'm sketching my velocity function, I think the x-intercepts are a good place to start. So that means my velocity is going to be 0 right here at 0, 1, 2, and 3. Those are the places that it's crossing the x-axis. And I'm really going to lean on my sign chart over here. This is really what I'm going to be looking at. It helped me in the last problem. It's helping me in this part of the problem too. So let's look at between 0 and 1. Between 0 and 1, we said that our velocity should be positive. If I'm graphing velocity, right, I'm graphing velocity in red, then my red function should be above the x-axis. So I know it's going to be above the x-axis, but I know I need to end up at this point right here again. So I don't want to go too far. Maybe look something like this. I can't draw it for certain, but this is an idea of what it looks like. Well, what about after 1? Between 1 and 2, we said our velocity was negative. So between 1 and 2, my velocity should be below the x-axis. Perhaps it looks something like this. 2 and 3, what's going on there? Between 2 and 3, my velocity is positive. Rebound should be above the x-axis once more. We're going to be above the x-axis. Maybe it looks something like that. I don't necessarily know how high or how low it goes. I just know it's above the x-axis there. And then what's happening after 3? Well, my velocity is negative. So if my velocity is negative, that means I am below the x-axis. So perhaps I look something like that. Not a great function, but maybe we smooth it out right there. So there's our velocity function, v of t, or at least an idea of what it looks like. We can't know for certain. We don't even have any y values over here. But we at least have an idea of how this graph behaves. Last example, so yeah, we did that right here. Last question in this example, on what intervals is the speed increasing? Man, this question just keeps coming back. So alright, I'm going to graph speed. Let's graph speed in blue. How about that? We haven't used that color yet. Remember, speed is just velocity but always positive. So anywhere where your velocity is negative, we just need to reflect that above the x-axis. So let's see, this part right here, if I'm talking about speed, this part right here is fine. It's above the x-axis. But then after that, it's going to kind of bounce above the x-axis here because we know that velocity, or speed, can't be negative. Between 2 and 3, that part's above the x-axis already. That's fine. And then after that, looks something like this, perhaps. So where's the speed increasing, right? So where's the speed moving away from the t-axis, or the x-axis? So let's see, where are we moving moving away from the t-axis? So it looks like right here, between 0 to, let's estimate that as 1/2. My speed is increasing. So from 0 to 1/2. So 0 to 1/2, my speed is increasing. Because after that, look what happens. My velocity, or my speed graph, gets closer to 0. If it's getting closer to 0, it's slowing down. Then after that, it bounces back up again. So it looks like 1 to, let's say, 1.5 right there. We're moving away, so that means our speed is going up. It's increasing. So, okay, from 1 to 1.5. 1 to 1.5. And then after that, again, same thing happens. It starts moving back closer to 0. If our speed is getting closer to 0, that means it's slowing down. All right. 2 looks like, okay, we bounce back up again. 2 to, let's say, again, 2.5. There's really no way to know for sure, so I'll just take the midpoint. So 2 to 2.5. 2 to 2.5 right here. Our speed is increasing. But then it stops after 2.5, right? Because we start working our way back towards 0. If our speed is getting closer to 0, that means we're slowing down. And then after 3, what's going on there? Well, looks like our speed graph is always increasing. It's always going away from 0. So I would say then from 3 to infinity, 3 to infinity, our speed is increasing. So from 0 to 1/2, 1 to 1.5, 2 to 2.5, and 3 to positive infinity, our speed will always be increasing. So not a whole lot of new derivative rules or anything here. We're just really digging in this section, trying to make sure we understand exactly what the derivative tells us. And if you're feeling confident about that, then that's awesome. That's what we wanted to accomplish. If not, hopefully by the time we're done with our homework problems, we'll feel a little bit better about that understanding.